If you've watched my previous videos on component form, this video is really going to be a little bit redundant. If it's your first time looking at one of these videos, you just picked one at random, then all you're going to need to know here is that Vx and Vy, our x and our y components of our vector, can very easily be found by taking the magnitude of V, that's that 162 that we're going to be looking at, and for our x component, our adjacent side, we're going to focus on cosine. We're going to take cosine of that 351, our direction angle, and for our y component, we're going to use sine to find this value. And so we saw in the last few videos, this is actually just a very quick formulaic approach to taking care of this, which is honestly pretty nice. As you can see, I'm literally just going to jot down these values here. I'm going to plop them into place here. We'll double check that I didn't write anything down weird or wrong, which would seem unusual. And then we're going to go right to a calculator. You can see where I have this from the previous video that I had made. We're going to go in and just say that 162 times cosine of 351 equals about 160. That's interesting. It's very nice zeros there to kind of push that. So we'll just write 160 here. And we'll hope that this next one works out in about the same way. And we see, well, it does not, but that's okay. We're going to see negative 25, let's say 0.3. And then you have to stop and go, okay, well, hang on. I have one that's positive, one that's negative. And we'll notice that I mentioned this was a quadrant 4 problem. 351 degrees, if I were to sketch this on a coordinate plane, would be somewhere pretty close to here. And we're going to see that we have a massive component in the x direction right now. So this here would be that 160. This here would be that negative 25.3. I know in the fourth quadrant, I should be positive here and negative here, so that checks out. So this seems pretty good in that direction. So we're going to say v hat equals 160. We list x first, and then our y component, negative 25.3. And then what I want to do to really verify for myself, the one check that I think is the most consistent for me tends to be just to go ahead and run the Pythagorean theorem real fast. And in the last video, I mentioned that you don't have to worry about the negative sign here because we're just looking at magnitudes right now. And we see 161.9879. So any of these rounding statements here are going to push these values up pretty well. So the 8 is going to bump this 9. That's going to be 162 here. And even if you didn't, you get 161.99 or 0.988. I mean, these are very close to 162. And that's the result of these two being rounded. So this feels very good to me. I think that we did a pretty good job here. You could do a little bit more in terms of insight, but there's no real reason to here.